Thank you for joining James Technical Talk. Today's issue is digital systems. Create weak security environment for U.S. energy companies. An introduction. Energy companies have switched to digital computer systems to monitor complex machinery, and computer hackers have devised creative ways to attack these systems. Technology is progressing, and approaches utilized to attack have become increasingly difficult to detect. U.S. energy sector entities are reporting intensification in cyber-based attacks against the infrastructure, and the methods of defense lack sufficient protection against emerging threats. The Industrial Control Systems Cyber Emergency Response Team has accumulated cyber attack data representing varied sectors of the U.S. economy. Cyber attack data composed by ICS CERT details the energy sector receiving the larger attack rate throughout the economic sectors. From this, we can see that the energy sector in the pie chart can be seen as the larger share compared to critical manufacturing, or even like communications, commercial facilities, chemicals, plants. Very low. And even healthcare has very low marks compared to the energy sector. Medical support, as we mentioned, telecommunication services, militarized defenses, and manufacturing. Processes all depend on energy produced by the U.S. energy sector. The energy sector will remain at significant risk of loss in service, data, or money if strategic action is not taken. This dynamic explains why securing the energy sector is so important. The Supervisory Council and Data Acquisition (SCADA) networks that manage the energy infrastructure woefully do not provide the necessary security required to defend against the emerging threats. Due to ease of systems management, energy entities are converting to digital systems, yet the lack of robust computer network security present may not be sufficient to resist the cyber attacks that threaten supply. SCADA, a short history. 60 years previously, energy companies relied on exhausting processes to manage their equipment. In the 1960s, General Electric and Control Corporation finished building the first SCADA control system that could control mechanical equipment. These processes were time-consuming and required many workers to perform routine checks of equipment and equipment stations to ensure performance. In the beginning of the 21st century, energy entities initiated the use of digital SCADA networks spanning across a global environment, and the utilization of the Internet began a foundationally significant role in the way energy companies could communicate with remote equipment. This is stating the problem. Using digital computer systems to control equipment from remote locations created a security concern for the energy companies. In 2005, the U.S. and Israel governments created the first cyber weapon that could attack the SCADA network in Iran's nuclear program. By 2010, engineers of the Iranian nuclear facility found a computer worm that was destroying their equipment. The computer worm has been identified as Stuxnet, a strain of malware that was designed to destroy industrial equipment in the SCADA networks. The discovery of the Stuxnet worm attacking the Iranian nuclear program has inspired computer hackers to design their own strains of the malware. Dooku, Flame, and Goss are three new strains of malware that were developed from the same framework as Stuxnet. They are designed to attack the SCADA network of energy companies and can cause serious damage to equipment. Using digital computer systems to control energy equipment has opened a new avenue for cyber attacks as more companies are exposing their SCADA networks to the world. Defining a SCADA network, they are digital sensors, monitor and control a process that would react to an on-off or a yes-no input. Typical digital sensors to monitor and control SCADA network equipment would consist of level switches, pressure switches, generator status, nozzle and drain switches, relays, and monitors. Now, there is a group of professionals who will create maps of a SCADA network. This is what their mapping system looks like. What we had detailed previously is that they are exposing these networks, the SCADA networks, to the internet. Again, they do have firewalls, go off to servers, but this is the intrusion detection system, which we will talk about in a moment, which does the protection of servers here. The other side of the network, again, they still have firewalls. Go off to the router, and then these are their monitoring controls. So again, this may look foreign to some of us, but again, it's just a map of how network design folks will lay out a map of this technology. The methods of cyber attack, relying on digital systems to communicate with remote equipment. Again, energy companies have positioned themselves so that their monitoring equipment can be targeted within the cyber attacks currently available on the internet. Methods such as watering hole and spear phishing, both social engineering attacks, are created to entice companies' staff members by using their personal interests as a lure. SQL injection is used to steal database information from the web servers of energy companies. But there are current defense against cyber threats. Considering the looming threat that cyber attacks pose to the infrastructure of energy companies, there are methods of defense that are proven and still prove effective. Intrusion detection prevention systems are being used to defend energy companies' equipment. We saw that on the map. Penetrating tests and vulnerability analysis are useful ways of finding areas on a computer network that could be used by a hacker for access into the SCADA network. And a network administrator who uses these methods can protect company data and equipment. Conclusion. The SCADA computer network is the technical core of an energy company. There is an extensive amount of equipment that is used to control and monitor equipment. SCADA computer networks have entered the digital world. Cyber attacks that have affected various entities are utilized to attack energy companies. For the safety of the United States, defending these systems is serious. Currently, SCADA systems employed by the energy sector are vulnerable and open to attack. There are a number of ways to protect the SCADA network of an energy company. Additional to the terms of the technology employed, there are the terms of practices and procedures. This is very significant. The solution to protect the SCADA networks of energy entities is not a single resolution, but a series of practices and procedures that must be used to confirm security. Current energy companies have a duty to inspect the security level that the computer networks are capable of and address vulnerabilities that are applicable. Failing to defend the SCADA computer network of energy concerns could result in distressing harm to the industry and to the environment that depends on energy. Thank you for tuning in.